Alright, I got this footprint of the GPS module in the background, and I have my video here, the video feed from the camera pointing at the board. And moving on with this motor drive design that I've designed in KiCad, and this particular board I have soldered myself using solder paste and a stencil. I have also a few boards ordered from PCBWay, so we'll see how that goes out, if that would be any good. And I think it's going to be pretty perfect. As long as the design works, I think the factory manufactured board is going to be a lot better without any shorts that I've discovered. So many shorts in this board when soldered manually, because it's so easy to short little pins of the 402 components, which are very close together, and that creates extra problems that take time to solve. But so far, I've not had any major problems. I've had a little bit of an issue with this Zeners that I had on the 3.3 regulators, which were conducting current, so the regulator is actually not able to provide enough current without getting hot. I think this, even though this regulator is rated at 500 milliamps, I think it gets pretty hot even if it's supplying 200 milliamps. So getting as little current draw from these regulators is important. So I removed the Zeners, and on this prototype I will not have any Zeners that will clip any over voltage faults on the 3.3 rail in case some of the voltage from the there is basically a lot of circuitry that uses clipping diodes to clip possible over voltage faults, and I had the Zeners originally just in case the voltage on the 3.3 volt rail would rise above 3.3 volts. But I think it's very the chances of that happening are very, very low. So really removing the Zeners is not going to cause any significant issues, besides in case it does rise above 3.3 volts, it's going to be the job of the regulator to regulate that voltage, and there is not going to be any hardware protection against any overvoltage on 3.3 volt rail. Now the next step for this is the third board that I've where I've brought up the power supply, and the next step here is just to mount the resistors for the 3.3 volt regulators. Basically every regulator on this schematic has a current sense resistor on its output. So the current sense resistors both allow bringing up of each individual regulator by itself, which is useful, especially when soldering this board manually and getting a lot of shorts. It's useful to bring up each regulator by itself and make sure that each regulator works and that there is no short that feeds high voltage to low voltage output, and then to connect the current sense resistors to make sure that the current can flow to the rest of the circuitry. So in this case, I will mount the current sense resistor for the 3.3 volt regulators, and then we'll flash this STM32 with a simple program that blinks the indicator LED that's located over there. And once we have done that, we have proven that the 3.3 volt supply of the MCU works fine, and that we can flash any firmware to this MCU. And from then onwards, we can start bringing up the other parts of this board, which depend on having a firmware inside the processor. So let's do that. I will start my solder station, and I will just go on and solder the resistors. Where are my gloves? Did my dog eat my gloves? Where are my gloves? Oh, I found my gloves. So this board is designed entirely in KiCad, and you can see the full detailed design of this board in my other videos. From the point where I created the block diagram of this board and through all of the schematic design and PCB layout, everything is documented in live videos here on YouTube. So it's very nice to see a project go from zero to a board that's actually usable. I think that's pretty useful for anyone working on electronics. So that's what I decided to do with this project. Document everything. Let's see. If you're watching this live, you can comment feed, and if you're not watching this live, you can subscribe to my channel and get notified when I broadcast live, so that you can comment in the live feed. And that's a nice way to interact. And I find it useful, and I find it fun as well. Let's see, what is this? I have a little bit of a solder blob here. Let's see. There is a solder blob on this chip, which maybe is not an issue because it's on the edge, but it could be an issue if there is a pin that's shorted. And I think actually there is a pin that's shorted, so I need to remove the solder blob before something bad happens. Let's see if I can remove the solder blob. Can I get some wick in there and remove the solder blob? I almost get the wick there. Come on. Yeah. And the solder blob is gone. Awesome. So I think we should be able to power this on now. And we should get 3.3 volts on both the 3.3 volt MCU supply and 3.3 volt peripheral supply. Let's see here. So I'm going to power on the power supply, and I'm going to put my my multimeter there, and we'll see if we get 3.3 volts. I'm going to measure this here. We're not getting 3.3 volts, and is it getting hot? No. Let's see. Oh, of course. I'm such an idiot. So what I forgot here is to mount the resistor that goes between the 5 volt regulator and the 3.3 volt regulators. So I mounted the resistors that go from the 3.3 volts to the rest of the circuitry, but I didn't mount the resistor that goes from the 5 volt regulator to the 3.3 volt regulator. And therefore, the 3.3 volt regulator is not getting any power, and we're not measuring any voltage on it because of that. So let's see here. I'm going to place this resistor where it should belong. Come on, little resistor. Stop sticking to my tweezers. Get off. Okay. And I'm going to just solder this resistor onto where it should be. And then, after that, we should be getting 3.3 volts on both rails. Maybe we will, maybe we won't, but we'll see. So are we getting 3.3 volts on both rails? No, not on that one. And not on that one. What is going on? So what is going on? Is there a short? Or is there something else? Are we getting any voltage anywhere? We're getting 50 volts there, and we're supposed to be getting 12 volts there, which we do, but we don't get anything on the output of the 5 volt regulator. Why don't we get anything on the 5 volt regulator? Did I mess it up by heating it up? Maybe I did. It's time to unsolder this resistor and see. maybe the 5-volt rail is actually shorted. I'll check that actually first, because it could be that the 5-volt rail is actually shorted, but behind that resistor, so I haven't checked that, which would explain why it's not being brought up to the 5-volt voltage. So let's see if it's shorted. Yes, 5-volt rail is shorted, and because of that we're not getting any voltage past that point. So we need to figure out why the 5-volt rail is shorted. And I'm going to do that by checking the schematic and the PCB layout, and I will just highlight the 5-volt rail, and we'll see where it comes close to ground. So anything that comes close to ground is pretty much like pins that are close together, where you have the power pin and the ground pin, and there you could get solder blobs that short it to ground. So let's see if we can find this short. The short is supposed to be somewhere here, I think. So we have the 5 volts output here, and let's see where this 5-volt output is connected. So it's connected to some resistors and capacitors on the back there, and it's connected over there, and this goes to ground, for example. So there, that's a place where it could be shorted. So we have to check all of these places and make sure that none of them are shorted. Let's see. Could be shorted. We don't know. Let's check this capacitor. So somewhere on the 5-volt rail there is a short. We have to find it before we can power the CPU. And we have to make sure that there is no short. So I'm going to heat up the capacitor and just wiggle it around a little bit to make sure that there is no short underneath it. And then I'll move on to whatever next point I can find where the 5-volt rail gets close to ground. Let's see if this capacitor could be a potential. It could actually be a potential short because it has so much solder on it. Damn. There's so much solder on every single pad because the solder paste stencil got a little bit off the surface of the board. So what happened was that the solder paste got smudged. And at first I didn't think that was an issue. But after I have soldered the board, I realized that it probably was a big issue because any extra solder paste that ends up on the pads just causes a lot of problems. It shorts things, and figuring out where it's shorted is very time consuming. So next time I'm going to try to make sure that the solder paste stencil is fastened to the board as much as possible and doesn't move and doesn't lift off the board. Okay, come on. Maybe I removed too much solder here now in this capacitor. Maybe the capacitor won't stick because there is no solder left. Okay, I think it will stick. I think that's fine. And now I need to find any other places where this can be shorted. There, it could be shorted there, but I don't think it is. I think, let's see, so that's the other capacitor there. It could be shorted. Yeah, a lot of solder there as well. I'll solder this capacitor back and then I'll check if the short is gone. So the solder off, and now I'll just heat it up again and place the capacitor back into place, and then I'll see if the short is gone. Let's see if this... I probably should have the camera view for the sake of the video, because otherwise the video is going to be very boring, where you just see a still picture while I explain something that sounds fun. Let's see. Okay. Possibly that's going to be fine. Let's see. Yep. Okay, let's see if the short is still there. So we have a short on the 5-volt rail, it's still there. So there needs to be some other place where the short is happening. Let's see. We don't... Maybe on the bottom, but it's kind of unlikely. But it could happen on this capacitor though. So there is a capacitor here, which is the bypass capacitor for this chip, and if the pads of that capacitor have any solder blobs on them, they could actually be shorted. So I'm going to remove the capacitor and just... Actually, after this capacitor, I'll just search for anything that can be suspicious, instead of checking every single part that's on the path of the 5-volt rail. It's better to go with just the suspicious ones. I think this capacitor is fine. It doesn't have much solder on it. So let's see what else we have here. Let's see what we have over here. So this is another capacitor which could be shorted, but it doesn't have much solder on it, so it's probably not shorted. Let's see. And then there is this one. So on the back here we have a supply for the UX connector, and this supply could be shorted, but I don't think that there is not enough solder to short the pins of the capacitors that are on that supply. So I'm gonna look farther and see if I can find anything else. One of the probable causes is probably this. So let's see, we have 5-volt there, we have 5-volt there. Actually, we can check if the 5-volt is shorted to 3.3 volts, which would be very unfortunate. And it is. Check it out. It's actually shorted to 3.3 volts, which is a big issue. So what we need to do is make sure that this chip is not shorted. And I think I can see where the short is. There is one short here on this chip, and we can look which pins are shorted. Let's see here. So the pins that are shorted are over here. So it's actually possibly ground and PWM, but there could be other things shorted as well. And frankly, I don't really know if it doesn't look like there is a short on this chip, but there certainly is a short between the 5-volt rail. So it's important to get it to remove the short. Actually, I'll also check if the 3.3 volt rail is shorted. I remember checking it before and it wasn't shorted before, but you never know. So 3.3 volt, 3.3 volt for the peripherals, I think, is shorted. It's shorted to ground, so there is a short there as well. I'll try to get, I'll get rid of the 5-volt short first. So I'll see if there is anything else I could maybe desolder and solder back to make sure that there is no short. And it's quite likely that it is one of the either the capacitors or the chip itself that have, because there are solder blobs. I can definitely see several solder blobs on the components around this chip. And that's not good. So there is a few more places where 5 volts is connected, and one of the places is the USB connector, where I don't think the capacitor is shorted, and then there is the CAN bus. And I found another one, another short, which is here. I'm going to remove that with the leak. This is the problems you get if you solder the boards manually. So both benefits and drawbacks with soldering the boards manually. The benefit is how quick it is. It's much quicker to solder manually for a number of prototypes. Like I made 3 prototypes of this board, which I soldered manually, and turnaround is around 10 days. But then you have problems like this, which need to be dealt with. So that adds more to the time it takes to actually get a working prototype. But on the other hand, it's 7 days lead time on the components alone for the PCB manufacturer. So it takes longer to manufacture PCBs at the factory. And I also think it's kind of fun to do both, to solder a board manually and then get a board soldered at the factory and compare the two. It kind of forces me to think through the design again when I do this. So as I debug this, I also try to think of any improvements that I could make to this board. Okay, that one is soldered, and now we have this one. I'll actually add more flux to it. Maybe I never desoldered this chip, because I don't see any flux around it. Oh, god damn it. What happened to the video? Why is the video not live anymore? Did I lose my internet connection? God damn it. I think I lost my internet connection. Really annoying.